All right, so today we're going to be looking at something a little different. It's a programming language, and get this, it's praised for being boring.
You get that right. Boring, but in a good way, apparently.
Not boring in a good way. We're talking about Go, and we're going to try to figure out why some developers think that its simplicity is actually its biggest strength.
Okay.
Our deep dive today is based on a blog post we found from a developer who calls himself an old software plumber.
Okay.
And he's been trying out Go and comparing it to some other languages like Elixir and Python and even Rust.
That's an interesting mix.
Yeah, I thought so too. That combination of languages really got me interested.
Yeah, I can see why it really shows you the huge variety of languages used in software development these days.
Hmm.
What I find really interesting is the author's take on how minimal Go is.
Uh-huh.
They say that not having features that are usually considered essential in other languages,
Mm.
things like inheritance exceptions and pattern matching,
Right.
they say that actually makes Go more reliable and easier to keep up.
So that kind of goes against the idea that more features are always better, right?
Yeah, it really does.
I'm curious, for those of us who might not be super familiar with all those programming concepts, can you break it down for us a little? Why are things like inheritance so important in some languages?
Sure. Inheritance lets you create new classes that are based on ones that already exist, so they inherit the properties and methods of the original class. Think of it like building a virtual zoo.
Okay, I like where this is going.
You could have like a base class called animal with the basic stuff like age and weight.
Yeah.
Then you make subclasses like lion or elephant, and those would inherit from the animal class, but also have their own unique characteristics, like a mane for the lion or a trunk for the elephant.
Right, makes sense.
It helps you reuse code and keeps things organized in a hierarchy.
So how does God handle that kind of thing without inheritance? Does it just force you to start from scratch every time you want to make a new animal?
No, not at all. Go encourages a different way of doing things. It's called composition. And the idea is that you put together smaller reusable parts to build more complex things.
Interesting.
So instead of a strict top-down structure like you get with inheritance, you might have separate pieces for like a mane, trunk, or wings that you can mix and match to create all kinds of animals.
So you're not stuck with everything from the parent class, you just pick the specific parts you need. That's cool.
Yeah, it can make your code more flexible and easier to break down into modules.
I see. The author also mentioned that they were surprised. Go doesn't have pattern matching. Can you give us a quick explanation of what pattern matching is and why it's such a useful thing to have?
Imagine you're writing a program that looks at incoming data, which could be text numbers or even images.
Okay.
Pattern matching lets you define specific templates for each data type and then run different chunks of code depending on which template the data matches.
So it's like a smart filter that automatically sorts and processes your data based on the rules you set up?
Exactly.
Yeah.
It cleans up your code, making it easier to read and less likely to have errors. And it's become pretty standard in a lot of newer languages, so it makes sense why the author was surprised to see it missing in Go.
Yeah, for sure. So instead of writing a bunch of if-else statements to deal with each case separately, pattern matching offers a more elegant solution.
You got it. It makes your code more streamlined and less prone to errors. And as I said, it's become quite popular in many modern languages, so it's understandable that the author was surprised to find it missing in Go.
It definitely makes you wonder why the creators of Go went in a different direction. Is there something about Go's design that makes pattern matching a bad fit? Or is there another reason altogether?
That's a great question, and it really gets at the core of Go's design philosophy. To understand their choices, we need to dig a bit deeper into their priorities.
Okay, let's do it.
Welcome back. So before we get too deep into Go's design philosophy, I think we got to talk about the elephant in the room, or maybe the missing elephant.
What do you mean?
Well, the folks who created Go, they knew about features like pattern matching when they were putting the language together.
Oh.
It's not like they just forgot about it.
Yeah.
They left it out on purpose because of what they thought was really important for the language.
So they weren't just trying to be different just to shake things up. They had a good reason.
Right. They were all about keeping things clear, simple, and efficient. They thought a language should be easy to read, write, and maintain.
Yeah, that makes sense.
They wanted to make a language that lots of developers could use, not just the ones who were really comfortable with super complicated stuff.
It almost seems like they were reacting to how languages were getting more and more complex and packed with features. Sometimes it's almost too much.
Yeah, exactly. They were worried that adding too many features would make the code harder to understand, harder to debug, and just harder to work with in general.
So it's all about using the right tool for the job. Sometimes a simple, reliable tool is actually better than a fancy one with all the bells and whistles.
Exactly.
Yeah.
And keeping things simple has real benefits. For instance, Go code is known for being easy to read, even for developers who are new to the language. And that's partly because it doesn't have things like pattern matching, which can be powerful, but also make the code more complicated.
Right, so pattern matching can make some things easier, but it's also one more thing developers have to learn. And if you're on a team, that extra complexity can make it harder to work together.
That's right. And the same goes for other features. Go doesn't have exceptions in the traditional
How
sense.
do they handle errors then?
They use explicit error handling, which means functions return errors as a separate value.
So you have to deal with errors directly.
Yeah. It might seem like a step back, but it forces developers to think about error handling more carefully and write more robust code that's less likely to crash unexpectedly.
So it's like Go is saying, let's not ignore errors. Let's deal with them head on and make sure our code is ready for anything.
Yeah, I like that. It's a pretty refreshing approach these days when exceptions can sometimes be a way to avoid handling errors properly.
I see what you mean. And this focus on being explicit goes into other parts of Go's design too, right?
Exactly. Like Go has a very strict type system, meaning the compiler checks the types of variables and expressions when you compile the code.
Okay.
This might seem limiting, but it actually helps catch errors early on and prevents a bunch of bugs that you might see in languages with more dynamic typing.
So Go is all about trade-offs. They're
Mhm.
willing to give up some flexibility and expressiveness to make things more reliable, safe, and easier to maintain. And it sounds like in a lot of cases, those are good trade-offs.
Absolutely. It's about finding the right balance for what you need.
Hmm.
And speaking of finding the right balance, another area where Go's design shines is in concurrency.
Oh, yeah. I've heard Go is great for concurrent programming. Why is that?
Go was designed from the beginning to handle concurrency really well. It has built-in features like coroutines, which are lightweight threads of execution,
Right.
and channels which let coroutines talk to each other safely and efficiently. These features make it surprisingly easy to write code that uses multiple processor cores without having to deal with all the complexity of traditional thread management.
So you don't have to worry about all the headaches that come with multi-threaded programming.
Right, Go provides a much more streamlined and intuitive way to write concurrent code.
That sounds pretty awesome. So instead of dealing with locks, mutexes, and all those other tricky things, Go gives you a simpler way to do it.
Exactly. And this is another example of how the creators of Go made choices to make common programming tasks easier. They wanted to make concurrency something more developers could use, and they definitely did that.
Okay, so we've talked about Go's focus on simplicity, its emphasis on being explicit, and its approach to concurrency. But how do all these features actually work in real-world projects? Why would someone pick Go over, say, Python or Rust for a specific task?
That's a great question. To answer that, we need to look at the kinds of applications that Go is particularly suited for.
So we've been talking about Go's design philosophy and how they really focus on keeping things simple and efficient. But how does that actually play out when you're choosing Go for a real project?
Well, if you remember our old software plumber from the blog post, he specifically said he liked Go better than Rust for command line interface applications.
Oh, right. And he even mentioned that Rust has a really strong community and a whole ecosystem, especially for things like Debian packaging.
Yeah.
That kind of makes me think that Rust is used more for those complex system-level applications where performance and safety are super important.
Exactly. Things like operating systems, embedded systems, or high-performance networking tools. Rust gives developers a lot of control over system resources, which is perfect for those kinds of projects. But that level of control means there's a steeper learning curve.
Makes sense.
Go, on the other hand, finds a good balance between performance and ease of use.
Hmm.
So it's a good choice for things like CLI applications, web servers, and other back-end systems where developer productivity and maintainability are key.
So it sounds like Go might be a better option for someone who's just starting a new project and needs to get things up and running fast, especially if they don't need that low-level control that Rust offers.
Yeah, that's a good way to think about it. It's like if Rust is a super precise scalpel for delicate surgery, then Go is a reliable workhorse that can handle a bunch of different tasks really well.
I like that analogy. It really shows that there's no one best programming language out there. It all depends on what you're trying to do, how experienced you are, and even the culture of your development team.
I totally agree. The main takeaway here is that boring isn't always a bad thing. In programming, simplicity and reliability can be really valuable. Sometimes the best solution is the one that just works without any drama.
It's true. Sometimes less really is more. This whole deep dive has really shown me how important it is to think critically about the tools we use and not just chase after the newest trends or features.
It's all about making smart choices.
Yeah.
And yet, Go might not be the most glamorous language out there, but its focus on practicality and clarity has really connected with a lot of developers.
Well, I think that's a great place to wrap up our deep dive into Go, the programming language that's not afraid to be boring. We've explored its unique design philosophy, its strengths and weaknesses, and how it compares to other languages like Python and Rust. Hopefully, our listeners now have a better understanding of what makes Go special and why it might be the perfect tool for certain types of projects.
And maybe they'll even be inspired to try Go out for themselves. Who knows? And they might just discover that boring can actually be pretty exciting.
That's right. So until next time, happy coding, everyone.